All right, now we're going to use those special angles and special ratios that we calculated to create the unit circle. So we know that as long as the R value is 1, and I'm dividing by 1, or a hypotenuse of 1, then my opposite, or my Y value, is always going to be my sine. And my adjacent is always going to be cos. So going from 0 to 90 degrees, I can state that my cos values are going to be 1, root 3 over 2, root 2 over 2, 1 over 2, and 0. My sine values are going to go 0, 1 over 2, root 2 over 2, root 3 over 2, all the way up to 1. How do the coordinates length to the measure rotations? Cos of theta is equal to x. Sine of theta is equal to y. So I can state that the coordinates on the unit circle, x, y, are equal to cos theta and sine theta. Now remember, this is reliant on, this only works if my R value is 1, which it always is on the unit circle. Which means that as I'm filling out the unit circle, based on having the same reference angles, my pattern stays the exact same. I start with 1, root 3, root 2 over 2, 1 over 2, and go to 1. If I am on the back side of the circle at 180 degrees, my measurements stay the same, except for we know that in quadrant 2, my cos values are going to be negative. In quadrant 3, my cos values stay negative, but still have the same measurements based on the reference angle. And in quadrant 4, my cos values become positive again, but still have the same reference angles. Same thing with sine. After I put my positive sine values in for y, in quadrant 2, they're still positive. And then in quadrant 3 and 4, same values, but they become negative. So if I memorize what it is in the positive section, then all I need to know beyond there is whether x is positive or negative, whether y is positive or negative. And such, it will tell me whether sine is positive or negative, and whether cos is positive or negative. But I just need to memorize, really, this first section in order to do that. So in the unit circle, where r is equal to 1, we know that sine is y, we know that cos is x, and we know that tan is going to be sine divided by cos. So anytime that I get those exact values, I can just put in sine divided by cos. If I want to figure out what tan of 240 degrees is, then I would look at my unit circle and I would take my y value, negative root 3 over 2, divided it by my x value, negative 1 over 2, and that's going to give me positive root 3. So, based on the unit circle, if I have 240 degrees, go to 240 degrees, like I already have here. Sine is my y value. It's just negative root 3 over 2. At the same spot, cos is my x value right here. That's just negative 1 over 2. And as I've already said, and if it makes it easier for you writing it out like this, which some people does, tan is just going to be my sine divided by my cos. And if it makes it easier for you to solve, just multiply by the reciprocal and simplify the fraction to get that root 3. So, if I am going back onto my unit circle, cos of 135, there's my x value. It's negative root 2 over 2. Tan of 120. Go to 120. And I have root 3 over 2 for sine, negative 1 over 2 for cos. It's going to be root 3 over 2 divided by negative 1 over 2, which is the same as root 3 over 2 times negative 2 over 1. The 2's will cancel out. And I'm going to be left with negative root 3 as my final answer. If I need sine of 180, go to 180. My y value is going to be 0. So it's just 0. Tan of 270. Go to 270. It's going to be my y divided by my x. Negative 1 divided by 0. Can't divide by 0. It's just going to be undefined. Which is true. Anytime that I land on a y-axis, my tan value is always going to be undefined. Another way that we could do this is I could ask you how much rotation occurs between 2 points on the unit circle. So I have point A, which is at negative root 2 over 2 and positive root 2 over 2. Go take a look at my unit circle. Negative root 2 over 2, positive root 2 over 2. That's at 135 degrees. For B, it is negative 1 over 2 and negative root 3 over 2, which I can see here is at my 240. If it's rotating counterclockwise, then it's rotating from A to B, which means that it's a positive value. So I'm going to take the bigger value, 240. I'm going to subtract from that the smaller value, 135. And I'm going to calculate that the rotation was 105 degrees.